Well, welcome everybody, and thanks for coming today. What I'll be talking about today is building an IoT system to protect my lunch from my dog. Thank you for the introduction. We'll be going through a bunch of different materials today that'll cover really everything from the high-level concepts you need to know in order to work with IoT on AWS to the very specific things that I did to create a Raspberry Pi device that's actually sitting right next to me right now that hopefully I'll show you in action in a little bit. So to get started, one more thing I have to close here. So to get started, let's think about what the big deal is about cloud and IoT. Embedded systems have been around for a little while now, but more recently, they've been getting more and more involved with cloud services and leveraging all the benefits that cloud services have. Right now, there's about 30 billion connected devices estimated in existence today, but that number is growing very quickly because lots of different customers are demanding more and more connected solutions for everything that they're doing. There's also a lot of other important stuff happening at the same time with all those IoT devices. There's things like expiring root CA certificates, where the authentication mechanisms and the security between those IoT devices and the other things that they're talking to has to eventually be rotated to maintain secure. And lots of devices in the past didn't necessarily have a good, solid strategy for that sort of update and automation. So there's a lot of new work to be done even on those old devices. Now, another big kind of an important aspect of IoT right now is that we need to think about how we move towards maintaining these devices in the long term. It doesn't look like IoT is really going anywhere, so we have to start thinking about what's the strategy for remotely managing, remotely updating, remotely patching all of the billions of devices that are out there today. Or if there are devices that can't be patched, what are the other considerations that we, really have to make for that entire ecosystem? There's lots of other important and cool things that we can also do by integrating IoT in the cloud. Things like predictive maintenance and alerting on all the data that our IoT devices are sending around, and also automating and optimizing the data collection and storage that those IoT devices do. By hooking the devices themselves up with the cloud, we get a lot more options to do that. And finally, we can do things like business intelligence and reporting on all that data that's coming in. So, with all this kind of context out of the way, why do we want to do IoT on AWS specifically? Well, I think there's a very obvious answer, which is the fact that AWS has itself a suite of services to work with IoT devices and a lot of stuff built into that entire process to improve the security, improve the management, the lifecycle of those devices, and a lot of the different scenarios that you might be working with when you're working with IoT devices. So not just your kind of everyday Raspberry Pi that I have sitting on my desk, but plenty of other different kinds of devices that fit into a lot of other use cases. Now, in addition to the IoT services themselves, I think the possibly biggest selling point that differentiates different AWS IoT offerings from other places is that you also have the entire AWS ecosystem that you can put into it. So services like AWS Lambda, Kinesis, QuickSight, DynamoDB, and all the other services that you might want to leverage and integrate with IoT devices, you can connect pretty easily to that central IoT service and get things flowing in a pretty smooth way. Now, the first thing we have to think about when we ourselves are setting up IoT devices and we really want to get our own applications up and running is how do we authenticate these IoT devices to the cloud? Now, importantly, when I'm talking about this, I mean authentication and not authorization. And to distinguish that, when I mean authentication, I mean how do these devices prove that they are who they say they are, that they're a valid device that we have sent out some certificate to or some other form of identity that it can prove it is the device we think we're interacting with. We'll look at authorization and how authorization happens in AWS in a minute. So with authentication, some other platforms offer something like symmetric keys, where you have essentially a string that you have on the device and in the cloud to get the mutual interactions between those two resources to exist. But that gives you a few extra attack surfaces and isn't the most secure production example. So where AWS usually starts, from what I've seen with IoT devices, is using and leveraging X509 certificates. Now, these certificates are generated from a certificate chain, which we'll look at in a minute how that process works. And then a certificate is actually placed on the device along with a private key so that it can have its own unique identity and connect with its own unique identity to, for example, the AWS IoT services. There's other options though. You don't have to use X509 certificates. You could also use things like TPM attestation or other mechanisms that might be things like device claiming. You might have pre-registered device IDs and public keys somewhere in a database, and then a new device that you're adding goes out and tries to get its new credentials that way through an API. You could do things like certificate signing requests, where you have an entire certificate signing request process happen not during the manufacturing process, but rather at a later time. But usually, what I've seen so far in my work has been really more focused around those X509 certificates and TPM attestation, because those two processes can be automated effectively in a manufacturing process for devices that support certificates or that have the ability to add TPM attestation to their devices. And what that is essentially is usually another chip that handles all of the cryptography operations and deals with the signing of everything that happens inside that little piece on top of a device, so that you can use that to deal with what the certificate might otherwise be doing for that authentication between a device and the cloud. Now, there's also authorization mechanisms, which I distinguished before. Now that we've had our device, we know, for example, the Raspberry Pi device, say we put an X509 certificate on it, and we know it's the right device that we think it is. We need to know how many permissions and what kind of permissions it has inside of our cloud environment, because we don't want it to have access to everything. And we might want to make sure that it has the proper permissions to send information where it needs to go or to retrieve information from where it wants to get it. The first thing we'll probably do with our IoT device is to set up IoT Core policies inside of AWS IoT Core. And these policies will help determine what the devices can do, what MQTT topics they can subscribe to, what MQTT topics they can publish information to, and otherwise how they can interact with that service. But there are other ways, depending on the types of IoT devices you're working with, and also depending on whether or not you consider things like mobile phones or watches, things like IoT devices. And I do in this case, but you kind of have a mental shift because they're also like user-based devices for kind of lay users. And in that case, we might start thinking about how we integrate things directly, like AWS IAM policies and roles, both with IoT Core policies or with things like Amazon Cognito, if we have users signing up in a web application and then having that identity be carried over to give it permissions to take some action inside of a web application or even on our backend services. And inside of some of these, there's also the options for integrating with the STS service in AWS to get tokens that are short-lived to deal with actions that you need to take against AWS APIs. So now that I have those two kind of general concepts delineated and differentiated a bit, let's look more at X509 authentication. This is the one I'll really be focusing on for this talk, because it's the one I see coming up the most often. Now, with X509 authentication, I really glossed over what that is. The way that starts is with something called a root certificate. Essentially, we create this root signing certificate, and this can be registered inside of AWS so that we have this high level, essentially, authority here that knows if the lower level certificates that we're eventually going to create are authentic. And then what we do with that is we create something called a signing or an intermediate certificate, which can then itself create other certificates. And this down the chain is how we authenticate from the top level down to the lowest level for single certificates on particular devices. Now, when we create these leaf device certificates, it allows us. Maybe there's a question there. I'm not sure. I can't see any of the video or anything else. So if there is, feel free to pop in. I just heard some audio. But with the Leaf device certificates, essentially what these allow is the in devices to authenticate directly to the cloud using those Leaf certificates. And they're stored securely on the device to do that. But they also avoid us having to reuse something like a symmetric key or API key that we're storing inside of the system. Usually that'll end up leading to some sort of bad practice where if you just have a string that's maybe a 20 character string as your key, maybe some some developer is going to leave that in the code. It might be easier to get lost, or might be easier to get exposed later on. But if you have this unique certificate for every single device in your entire process, then that makes it a little easier to be sure that you're not using the bad practices that sometimes those keys will promote. It's not to say you can't do it right with symmetric keys. It's just that it's a little bit easier to ensure that with X509 certificates or some of the other methods I mentioned. So let's look at how this works in practice in a manufacturing process. So let's say we have our root certificate. Well, we're going to go ahead and create a signing certificate with that. And then we're going to say, let's take this root certificate and let's make sure we register it inside of AWS IoT Core. Then this process will essentially let the IoT Core know that anything signed by this root certificate should be good. It should be good to go. We can trust it. We can make sure that we don't have to deal with any other issues that we might have. Now, there's other kind of complications here that definitely come up when you're dealing with the right way to structure what this is. This is called the public key infrastructure. And the right way you might want to structure this to ensure that if a signing certificate gets exposed, that you don't have to invalidate every single device, but you can invalidate a few of them, that the blast radius is essentially reduced. So keep in mind that this is a little simplified. But once that certificate is registered in AWS IoT Core, you can then take this signing certificate that was signed by the root certificate, and for your device manufacturing process, you can say, okay, for every one of these light bulbs, let's go ahead and give it a unique leaf certificate for each of these light bulbs. Now, these are all going to be individually unique certificates, but they're all signed by the signing certificate. So what this means is that they'll be trusted up the chain of trust through to the root certificate. And then AWS IoT Core will know these are good. We can trust that these devices are who they say they are. So once that process is complete, then you have to think about kind of the next step after you ship these devices out, which is provisioning them for the right permissions, the right details that they need, the right configuration information. And this whole process can happen in a few different ways. You can manually register devices and certificates in AWS IoT, but this isn't usually the most effective scenario because when you're mass manufacturing devices at scale, you might not even have access to Wi-Fi connections in a manufacturing environment overseas, or you might just not necessarily want to do that for each individual device because it'll take longer in that process where you're really trying to optimize how long it takes and how quickly you can get the devices out. So instead, you might do something like just-in-time provisioning, which in AWS is when you provision devices using a template that contains all the information that they'll then be applied to the device once it tries to go in and register with AWS IoT Core. And it gives it some metadata that's based and tied to the unique certificate on the Leaf device, and that's how you identify it and make sure you can tell those devices apart. But there is another option that gives you a bit more customization into what you can do in the background called just-in-time registration. And the way that this works is you'll have Lambda process an MQTT topic where that your devices might send their registration information to. And then Lambda in the background, AWS Lambda, will take those pieces of information. It can do any custom workflow you want. It can create your IoT thing in AWS IoT Core, which is kind of the identity for your device there. It can register the certificate that you're using with that thing. It could even attach policies that are customized based on what kind of device it is, maybe where it needs to be talking with, what sort of user might be attached to it. And there's a lot more customization there. So you have these two kind of disparate options right here, where one, you have the template that'll apply kind of the same thing every time, and the other one that's a little more extensible with Lambda that'll let you do your own customized workflows. Now, you can also do things like provisioning via a trusted user, and this might happen when you have an authenticated technician or maybe a customer gets a certificate for the device, and you need to do this more in kind of a manual way where the device gets shipped to a location, the technician goes in, with their Cognito web app in their iPad that they're, at administrator level, they read some serial number off the device that ties to a certificate potentially, and they hook everything together that way a little bit more manually. It's definitely still an option. There's also another option to use something called a claim certificate or a claiming certificate. And what this does essentially is a shared certificate that's used to get a device's unique certificate. So it's a little bit less secure when you think about the blast radius of how this works, where if your claiming certificate gets compromised, you can't use it anymore. And you have to look at how it could be used in the future to create new devices. But because the devices only used it to get their own unique certificates, you kind of have a better security scenario than, for example, something like you're using the same authentication credentials on every device. Okay, so that's a little bit of talking, but let's visualize that one more time. So with just-in-time provisioning, let's say we have our IoT device and it has its leaf device certificate that's signed by the intermediate or signing certificate all the way up to the root certificate. So what it can do is it can say, hey, AWS IoT Core, I'm here, I've got my certificate. IoT Core says, that looks good. It looks like we're evaluating this whole chain up to our red certificate here, that smallest one. And so it should be good, and we can go ahead and go through the process. So what it'll do is it'll go look for the template that's configured with with this root CA. And I'll say, okay, I've got this template. I want to send you the information back around that template, and I'll go ahead and configure the IoT thing, something called the device shadow, which has the state information for your device and a policy that says what you can do. So that's essentially all you need to do in that just-in-time provisioning process. With just-in-time registration, you have the same device with the same certificate chain and private key, and it says, hey, AWS IoT Core, let's do this again. AWS IoT Core says, oh, okay, well, I see you're sending a message to an MQTT topic, and this MQTT topic is usually called something like register. I believe this. I'm remembering this correctly. And then a Lambda function is sitting there watching that topic for all the information that our device is sending in for the first time. That Lambda function then goes and creates all those resources, and IoT Core has all access to all of them, and then so does the device. So this is a really kind of high-level overview of how these different processes work. But what we're going to do is go from this theoretical process right now over to looking at the demo that we'll be doing today, which is related to a Raspberry Pi device that I have set up on my desk. Now, if I have chocolate sitting on my desk or any other treats that I want, I want for myself, and I don't want my dog to get access to, especially if it's chocolate, and to keep her from jumping up on my chair and trying to nibble on anything, I've set up this Raspberry Pi device and this PIR sensor, which is a passive infrared sensor that essentially allows me to detect motion in front of it when I wave my hand or there's infrared changes in front of the sensor. And what that means is that I can get notified whenever my sensor is disturbed. So what I've done is I put a really simple web application together to really just get us access to the latest time that the sensor was disturbed, and also to send me text messages through Amazon's simple notification service whenever I see any changes on this. Now, what this has done is not only had the standard PIR sensor set up to my Raspberry Pi and plugged into the right GPIO pins on that Pi, but it's also a few other pieces inside this application. Obviously, we have the easily stolen chocolate, but let's take a look at our code too. So our application code is really broken into three different parts. There's the parts of the application that we really have running consistently, which is our backend and our front end. And then there's our manufacturing process, which I've kind of simplified a little bit in our example, but we'll give you an idea of all the pieces that need to go in here. So for our manufacturing process, what's in here is we have a few different scripts and pieces that can live directly on our Raspberry Pi, or that we need to run beforehand to create the CA certificate that I talked about, to create the intermediate certificate, to create the device certificate, and then to register everything inside of AWS so that it has that top level certificate all set up. So the top and the bottom file that you see right here, connection attempt.bash and run.py, these two will be used directly on the device to run a MQTT library and MQTT tool to send messages directly to AWS to be processed by our backend. The rest of these scripts are really just to allow us to create our own self-signed CA certificate, which might not always be the case in a production environment because we might buy it from some other vendor, where you can think of like a VeriSign or one of the other companies that sells those sorts of certificates to allow you to use them for other purposes, to be trusted by other applications too. And then after we do that whole process of creating the top level, we create our device level certificate, and we also have a provisioning template. In this case, I've called it permissive provisioning template because it allows us to do basically anything from our IoT device inside of IoT Core. We can send messages to any topics, we can receive messages from any topics, and you might want to tighten that down a bit more in your own production applications to make sure that you can't use one device to interact with another unless that's actually what your application should be doing. So Now that you have a brief look at some of these files at a high level, let's look at the front end, and we'll dive into some more of the details of this code later. It's pretty simple. It's really just an index.html file, a little bit of JavaScript, a little bit of CSS to get us a basic application that we can then deploy to a tool called Vercel, which allows us to get our front end out pretty easily. In terms of the backend, we have a few more pieces here. In this case, I'm using something called the serverless framework, which allows me to deploy AWS Lambda functions and API gateway endpoints pretty easily. And we'll take a look at how some of this code works. The top part, which is the handler section, is really what these Lambda functions are doing. We have a function that's going to process an alarm if I wave my hand in front of the PIR sensor, so that we can get a notification when that happens. There's also another function which allows us to get the last state of when our alarm was triggered from our device shadow. And that'll tell us the last time my dog tried to jump in front of the PIR sensor and grab it. And there's this just-in-time provisioning handler, which is when I initially connected my device to AWS IoT Core and it tried to provision. This is what we used in order to get access to that template and to make sure that that'll happen. And there's actually two ways that we could do this that I told you about. This is the one that allows us to manually do the provisioning steps inside of Lambda, whereas the other template I showed you earlier is that kind of more automated way without the less customization. Okay, the rest of it is really just how we create some resources in AWS, and we describe them in YAML in a syntax very similar to CloudFormation. And with that, let's go ahead and jump over to the live portion of the demo. So let's go over here, and I will load up my editor here. We'll take a brief look at what's happening on my device. So I will go to run.py. And if you have any issues seeing this, I'm going to try and make it a little bigger. But if you have any issues seeing this or need me to adjust anything, please, moderator, if you could unmute yourself and tell me, because I can't see any of the screens right now. So what's happening here is really a very simple Raspberry Pi script that you can use and run on a Raspberry Pi device that you have. By default, Raspberry Pis on their Raspberry Pi OS come with the GPIO 0 or a Raspberry Pi kind of style interactivity with the pins that are on the physical device. I'm going to try and show those, but we'll see if my cable will extend far enough. So right here, I've got it running. I've got it turned on. You'll see there's a few pins and cables down on the bottom part of it here that plug into my my PIR sensor. And what is configured in here essentially is by default, it has libraries that allow us to actually interact with PIR sensors. So this motion sensor library is already containing all the code I need just to detect motion from in front of the PIR sensor. The only configuration I pass into it is this 4 right here, where if you took a close look at my Raspberry Pi when I was showing it to you, there would be one of my cables would be plugged into that pin right there. The rest of everything else that's happening here is really just a really basic while loop that loops and continually waits to see if there's motion in front of the PIR sensor, at which point it goes and calls my bash script because I was lazy and it was easier to write this in bash instead of translating it all into Python. And this essentially just it takes the certificate information that's on this device. So it finds this device cert and CA cert, which if we actually look at my Raspberry Pi device right now, I'll show you what's inside of here. I have this device cert. I have this device cert and CA cert. These two files are a private key and the certificate chain that authenticates this device. And when I use them together, I can create this MQTT message that I can send into AWS at this endpoint right here with these pieces of information. And this will trigger the alarms inside of my function that'll go over to my backend. Now, I'm not going to look too much at the actual creation and setting up of the Raspberry Pi because that takes a little bit longer than I have time for. But I'll have some guide links at the end if you want some of the basics on getting started there. So now that we know a little bit about what's happening on the device, let's see what happens on that back end. So I mentioned that there's these handlers. They're going to allow us to process the details that are coming in from IoT, from the IoT device into IoT Core, then going on to the device's shadow with all the details and information about it. What I've done is I've set up in this, you can ignore a lot of this, it's all just syntax for configuring these functions and the basics of these API endpoints that they work with. What I've done here essentially is set up an event that looks at the particular information related to any of my devices and alarms that they're sending the information to. And it says, as soon as we see that information, go ahead and send that over to our process alarm function to be processed. And if you looked back at my other Python and Bash code, you'd see how I sent that over to that endpoint. Now, I'll have all this available afterwards. If you do want to request it, you can definitely reach out to me. So now that we know how that gets there, what this essentially does is it sets up a little bit of Python code to get the state of our devices if we wanted to do that, and then to update the information inside of those devices' state, and then to also, you'll now know my cell number, so I'll hide that from you a little bit, but then to publish a message over to my cell phone number and let me know that my security system just detected some motion. So that's essentially all that this does. It just goes in, updates the information inside of our device's state, our device's device shadow, and then sends me a text message to let me know, hey, the PIR sensor moved. So let's give this a try before we move over to the other portion, which will be reviewing how this happens in the front end. So I'm going to pull up my phone here. Hopefully nobody will text me from the audience while I'm trying to test this, and we'll get it. Okay. So since I'm already right here SSH'd into my Raspberry Pi, this is my Pi, this is my home system. I can't do anything from there right now. What I'm going to do is I'm going to run this run.py file. So let's go ahead and do Python 3. Now let's do run.py. So now this should be turning my script on. It shouldn't give me any response right now because I haven't done anything yet, but I'm going to be really obvious with my hand motion here and go in front of the sensor. And it just detected that my hand moved in front of it. And if I show you my phone right now, it just sent me a quick text message notification letting me know that my dog, who also happens to be my background here, probably moved in front of the sensor, and I should go check it out right away. Now, really all that happens here is every once in a while, the PIR sensor will reset, and it'll allow me to kind of continually get notifications. I have to hold it really steady, though, because it keeps thinking I'm moving because I'm slightly moving the device. So I'm going to try it one more time, and we'll see if we can do it. It's also waiting for me to stay still enough, but there we go. It did it again. So you all triggered the sensor this time. So with all of that, I'll keep getting notifications and I'll keep getting more text messages. I think I have 4 or 5 of them now. So I'm going to go ahead and cut this one and turn it off with Control C. But now that we've gotten all those notifications, what if we wanted to create our own web apps with this that interact with the data that's being generated from our device? Well, that's what we've done in the front end section here. So let me move over to that instead. Let's go ahead and go up here, see what's in here. Let's go into our front end. So inside of here, we have all of our different files that are making up our front end. But let's see what this actually looks like in practice inside of everything here. Let's load this. Oops, wrong screen here. Let me load this up. So what I've done here is in the back end and the front end, I've configured a web application that I've deployed with this tool called Vercel. And I've also configured it with Cognito for authentication, so I can just sign into the system. I've already created a user account and saved some of my credentials here in my browser, so I'm going to sign in pretty quickly. But it looks like that it's just finished recording and updating the last time I got this. So it looks like 11:48:49 right now. That's about the right time. It's telling me, hey, this was the last time anybody tried to go in front of your sensor. And what this is doing is from the front end, it's actually hitting an authenticated API that requires me to have signed in with Cognito to go and access the information about this device and see the information from its device state, from its device shadow as to when it was last updated. And that's essentially all we have to do here to get the information both to our phones and to a web application. And inside of this, if you really looked at all the code that I've written, it's probably under 700 lines or something. Probably even less if you only really count the back end and the front end portions and ignore a lot of the extra stuff I have to do for the manufacturing process. Now, if you wanted to change anything in the front end also, you could hop in here. And because it's built with Vercel, it's actually pretty easy to do. You can just hop in here. Let's say it's our dog monitoring system now. Let's change that both in the title and I think I have somewhere else. It's our lunch monitoring system, but now it's our dog monitoring system because really that's who we're keeping an eye on. Let's do this, do a commit. We're monitoring our dog. And let's just go ahead and push that. So what this will do is it's essentially integrated with a bunch of CI/CD in the background. It'll allow us to, after we push the commit, get picked up by Vercel, go out and update it and do a new build, and then eventually just have that slight change updated here. And that's essentially the whole application. And if anyone has questions, I know I'm probably getting a little closer to time, so I'm happy to answer those if that is the correct time to answer them. Otherwise, I'll be inside of the link later on, the face-to-face link that I posted in the Slack. But I'm not sure if I'm able to post that in this meeting, but I will try and do that as well, so that you all can ask me any other questions that you have about it. Um, yeah, I think with that, that's all I have for right now. I'll refresh this page just so you can see that we're changing now to our dog monitoring system instead of our lunch monitoring system. Thank you all for coming today. I appreciate it. And if you have any questions or you'd like the guides that I mentioned, those are all available either on my blog. I put every guide I write or link to every guide I write on my blog. The more IoT related ones right now are through my employer's blog at witekio.com/blog. And I'm happy to answer questions right after this in the meet link that I posted in the Slack and in the chat just now. But also feel free to reach out to me afterwards on Twitter or somewhere else if you want to take it there too. Thanks, everyone.